Chapter 22 talks about the difference of proportions. A survey of 430 randomly chosen adults found that 21% of the 222 men and 18% of the 208 women had purchased books online. Is there evidence that men are more likely than women to make online purchases of books? Test an appropriate hypothesis and state your conclusions. All right, so notice that in this problem we are comparing two groups. We have men and we have women, and we want to see if there's a difference. We're going to set this up very similarly to how we did single proportions. So first thing we need to do is we need to write our hypothesis. So we have our null hypothesis, and we are going to say that the proportion of men equals the proportion of women. That's what we're going to try to find evidence to test against. If that's not the case, we have our alternative. Here it says that men are more likely. So we have the proportion of men being greater than the proportion of women. In your book, you might also see this written as the difference of men and women is 0. There is no difference. And my alternative would be the proportion of men minus the proportion of women is greater than 0. Think about it. If I brought this to the other side, it would still be the same thing as this over here. Now that we have written our null and alternative, it's important that we check our conditions. Same as for single proportions, except we just have to include both groups. So first thing, it says random up top, so we know that both groups are selected randomly. Less than 10%, we want to make sure that I have less than 10% of both men and women, which I do. So less than 10% of all possible women and men. Third condition, I actually want to make sure that both groups are independent of each other. So one group being that the men buy books online should not influence whether or not women buy books online. In the last condition, I need to check that I have 10 successes for men and 10 failures for men, and at least 10 for women of each. So you can see here that I did the math. I took the proportion times the total number. So I had N here and P, N times P. I got 47 successes for men and 175 failures. Successes meaning they purchased a book online, failures meaning they didn't purchase. And then over here for women, I took the N times the P, and I had 38 successes and 170 failures. All of these are greater than or equal to 10, so I've met that condition as well. Now that I've done that, I can go ahead and run my test. We're going to do this on our calculator. We're going to go to Stat, Test, number 6, because we have a 2 proportion, and we're doing a test. So 2 proportions you test. You should see these 4 things that we need to enter. So X1 is how many successes we had for men. Since I put men first over here, I need to put men first here. So go back to your conditions. We had 47 successes out of the 222 men. For females, we had 38 successes out of 170. Remember that you can only enter integers into these 4. The next part, it asks you to pick a symbol. Well, in our hypothesis test up here, we picked the greater than, so we are going to select the P1 greater than P2, the last function, and then go ahead and hit calculate. The 2 pieces of information you need to report here are your Z, which is how many standard deviations you are from the mean. And we got negative 0.28, and our p-value. So p equals 0.61. This is the probability, or what are the chances that given my null is true, so if that is in a fact, what are the chances I got results like I did? How common are they? There's a 62%, almost a 62% chance that my results could happen if this was true. Remember, in statistics, that's a really strong probability. So we're going to write that final sentence, and I kind of ran out of room here, so I'm going to squeeze it in down below in part B, where you should have room, plenty of room to do the next problem. So my conclusion sentence is with a high p-value of 0.617, we fail to reject the null. There's not enough evidence to suggest a difference in the proportion of men that buy online books versus the proportion of women who buy online books. Keep in mind that I probably should have listed my alpha in the beginning. 0.10 would have been a good cutoff since there's no real significance of having a smaller error here. So that is 0.617 is way greater than 0.10. Part B, estimate the difference if you concluded that one exists with a 95% confidence interval. Interpret that interval in context. We didn't think that there should be a difference from the hypothesis test, so we'll kind of confirm that with our confidence interval here. We have already checked our conditions, so we don't need to check them again. So we are going to go ahead and create a confidence interval here. Again, we have a 2 proportion, and we have Z interval, because we're looking for a confidence interval here. So this is, in our calculator, stat tests, and go down to letter B. All your data should already be entered if you haven't erased it from the problem before. So you should see the same information we had before. And we want a confidence level of 95. Go ahead and hit calculate. You should get 0.0943, and that's negative, which makes it a little bit tricky in our wording at the end, to 0.0707. Our concluding sentence from this is we are 95% confident that men purchase online books between 9% fewer than to 7% more often than women. So that wording seems kind of weird. But remember, in our initial hypothesis, we had said that proportion of men should equal the proportion of women. And we are saying that there really is no difference. So when I go back down here, I can see that sometimes men are going to buy books more often, and sometimes they're going to buy it less than. It's key to interpret this negative correctly. Okay, usually when we see a negative there, we're going to use the words fewer than, and we'll range up to a positive, so that we'll use more often. What do you notice? What is the key number that's inside this interval that concludes our hypothesis, or that goes along with what we said in our hypothesis, our null alternative? You should realize that 0 is inside that interval. 0 would mean that there is no difference in the proportion of men and the proportion of women. So because 0 is in our interval, this agrees with our hypothesis test conclusion. So as you can tell, doing a difference of proportions problem isn't too much different than when we had a single proportion. We just are going to use different functions in our calculator and making sure that each group that you are looking at is independent from one another. In 2000, the United Nations claimed that there was a higher rate of illiteracy in men than in women from the country of Qatar. Fun fact, it is the world's richest country. A human organization went to Qatar to conduct a random sample. The results revealed that 45 out of 234 men and 42 out of 251 women were classified as, that should say, illiterate on the same measurement test. Do these results indicate that the United Nations findings were correct? See if you can go through the test on your own, but at any point you can follow along with my work. So I've set up my hypothesis, my alternative based on the fact that it asks, claim that there was a higher rate of illiteracy in men than in women. All my conditions have been checked and I'm good to go. So I am now going to do a 2 proportion z-test. When I run the test, I get z 0.716 and p 0.237. If I had an alpha of 0.10 to begin with, again, this is a high p-value, so I'm going to write my concluding sentence. With a high p-value of 0.237, we fail to reject the null. There is not enough evidence to suggest a difference in the illiteracy rate for men and women in KDAR. So Part B asks us to find a 95% confidence interval for the difference in the proportions. Interpret the interval in context. Based on my hypothesis test, I know that I should get results where 0 falls in that interval. Go ahead and run that interval on your calculator. Running that interval, we see that we get negative 0.0435 to 0.0934. Now you just need to interpret that interval. We are 95% confident the proportion of illiterate men in KDAR is between 4% lower to 9% higher than women. Since 0 falls in our interval, this confirms our results in Part A, where we rejected the null.